Hey everybody, I'm Chris. This is Kersey Fabrications, and it is New Year's Day. I'm streaming live here on YouTube, and I appreciate everyone that's already here at the beginning of the stream joining me. What I'll be doing today is working on the new printer I've designed. I'm calling it the Cosplay 600. It's 600 millimeters wide, 400 millimeters deep. I've designed it for specifically for printing large cosplay items like chess pieces. I guess I get started. If you'll look up here, you'll see this is my screen. I've got my Fusion 360 design up in the window here, so that you guys can see what I'm looking at as I'm building this. Keep in mind that I've never built this printer. This is one that I 3D designed. I've got, I believe, all of the parts finally to get this built. But you know, this is a live stream. If I run out of a component that I need, or if I hit a roadblock, that'll be it for the stream, unless you guys just want to sit around and talk and chat about what I'm working on or what I have planned for this channel. So I think we're hopefully going to finish with the base today, which will be all the Y motion components, as you can see here. I'm going to do my best to stay involved in the chat as I see it pop up. Keep in mind that I'm probably on at least a 10-second delay with YouTube, and that's so that people can rewind and fast forward in the stream up until live. Again, some of these pieces I've test fit before, some of them I haven't. So I'm hoping we won't run into any major problems as I'm working on this today. And hopefully my computer will also cooperate. It looks like I might need to get me a mouse pad. Let me see if my notebook actually will do much better with this. Maybe, maybe not. Let's see. Alright, so no one's chatting yet, so we will get going with the print. I can see everyone can see what I was working on in Fusion. Let me get that up here. Looks like it just doesn't want to be far away from the system, so that's going to be fun as I go off camera here to try to use my mouse. But anyway, let's get this going. See if there's a better way to do chat, maybe on my phone or something. There we go. I gotta turn off sound though. Alright, so that does look like a better way to do that. I'll keep the chat up on my phone, and I will keep Fusion 360 up here. And let me get this sound turned down though, because that's not going to help. Alright, so let's get started. As you can see, I've got up the bottom of the printer here, because that's where I'm going to start. Each of these extrusions here are 700 by 700, as you can see as I pop them up here. That's 700, and so is the other one. These are also 700. And I have already cut down these internal extrusions which hold the Y rails, and these are 660, as you can see here. So again, feel free to interact in the chat with each other. Ask me any questions as I'm going. I think this is going to be a lot more interesting if people are chatting than if I'm just talking to the camera. But so let's get going. So these, let you know, most of the hardware, particularly the extrusions, all came from ZYLtech. They've got incredible prices. They'll do custom cutting for you. And again, I bought all these. This isn't a paid endorsement or anything. So let's get going on these. First of all, I will take off all of the nice plastic protection that they have on these to protect the finish. Hopefully I won't do any damaging as I bang it against the table here. I've got about 2 hours on this build, and we'll get as far as we can. If Also keep in mind, I have a family who is still living in the house while I'm doing this. So there may be background noises, or they may come in to ask me a question. We'll see. There's one. Again, all of these on the base, I tried to keep them. I mean, my ultimate goal for this printer is to release it to the general public to improve on or make clones of or whatever once I have one of them up and functioning. Hello 3D Print Viking and Marius. Appreciate you joining me. If you don't chat, I can't tell if you're here. So there'll be no shout outs to people that don't at least say hi in the chat. So again, we got 2. Sorry about the banging. Hopefully that doesn't kill any of your ears. But I think my microphone will prevent it from being too loud. It has clipping. So all of these extrusions came pre-cut, except for the 660s, which came as 700s, and then I cut them down on my chop saw. If anyone's interested, I can share later the blade I use. I actually found a really nice non-ferrous metal chop saw blade that work on these extrusions. I mean, it cuts just like wood. So if you have like a chop saw that you use for doing construction work, and you'd also like to use it for this kind of stuff, it worked really well. I had no problems cutting these down. So let's get all 4 of these. Only complaint I really got is I've got little shards of metal that I'm going to have to vacuum up later from the cutting process. These were cut with the plastic pieces on, and so because of that, it is leaving little shards. You can probably see that on there. Not sure, but estimated cost for this project. That's a good question. Particularly since some of this, like the base plate of the printer, has to be custom cut. So what I'm considering doing, if there's enough interest in it, once I get one up and printing and actually validate that this works, I'm tempted to actually work with a local company to get the base plates made, because like I said, they either have to be custom machined or you have to make a mask of your own and try to drill these. But I can tell you from experience doing trying to drill these holes in a sheet of aluminum, a thick piece of aluminum, it doesn't exactly go where you want it to most of the time, which would be really frustrating if you spent 40 bucks on a piece of aluminum. Estimated cost, I think, if you order the parts from a good company, I've spread this out over several months buying parts, and actually probably more than several, probably about 6 months buying parts. I'm guessing it's about $700, which is way cheaper than buying even a Creality that's a similar size. But wherever you can get parts from. Like I said, ZYLtech made this a lot cheaper because the extrusions were so inexpensive through them. And you are talking about a 600 by 400 bed. In just a minute, I'll actually pull up the bed here so you guys can see what it looks like. I also have a close-up camera shot that I can switch to. It's only a 720p camera though, so I don't want to switch to it any more than I have to. But I want to make sure everybody's getting a good shot of what I'm doing. So let me know. What board am I going to use? The initial board that I'm using is just a, what is it? Now I'm going to forget the name of it. It is an MKS Gen board, if you're familiar with those. I can actually bring up my other printer here and show it to you. So I'm going to start with that. It's an MKS Gen V1.4. I should have remembered that. But it's one I've worked with multiple times. I'm very used to putting marlin on it. And so it's what I wanted to start with. Due to the fact that I plan on doing a quad heated bed, that means 4 individual beds that can be zoned. I'm either, in the long run, I'm either going to have to modify marlin and put my, add some code to marlin that I would submit upstream to the main source control. Or I actually may end up going straight to the 32-bit board. And you know, because I'm live here, I'm going to completely draw a blank on the name of that board. So hopefully you'll excuse me while I look it up real quick. One of you in the chat probably can get to it before I can. What is that board called? Anyway, it's the 32-bit board. When one of you guys tell me what it's called, I'll shout it out, because I have it up somewhere. Yeah, I know a lot of people are going to want to know the parts for this, and I will be happy to get you guys all the parts list. Again, the only reason I haven't released bill of materials already at this point, yes, the Duet. Thank you, 3D Print Viking. That's exactly which one I've been looking at. So I've been on the boards there already, and I know that the main developer has actually added multi-bed support to Duet. So given that would add a lot of speed to this printer, given the size, and given he's already got the code support there for it, I may order one. But I don't know, if you've already looked at it, you've seen that the Duet is not a cheap board. So I haven't decided whether I was going to order one yet. I've already spent a lot of money on this printer. So again, I'm going to start with the MKS. I'm going to drive each of those beds off of 4 separate MOSFETs, but those MOSFETs are going to, in the short run, just be tied together, at least the control line to those MOSFETs, so that they're all on or all off. And then, like I said, I'll either write code in Marlin to support it, or I'll just go over to the Duet, depending I'm going to see how well the MKS performs on such a large printer. If I get the speeds I want out of it. I'm not looking for crazy fast. I'm not looking forward to like 200 millimeters a second or anything like that on this, because I care more about quality of the prints than speed. Yeah, I know. It's so good. I completely agree. Everything I'm hearing about the Duet is it's a great board. The configuration's easy. Everything's web-based, and you put a few text files on there for configuration, and you're ready to go. The company that's backing those boards seems very strong, very oriented towards the customer. So I'm definitely willing to splurge sooner or later. But we're going to go with what I've got for now. I like supporting Marlin, good open source project. Although I do know the Duet is open source also. All right, so let's take a look here. Let's get this the base built here. And hopefully you guys can still see this in the upper left. I'm going to just turn this over so that you can see what I'm building. Let's lay it out. Hopefully I have enough room here. If I don't, then I'll have to move things around a bit, because this is pretty big. So if you noticed on the front of the printer, the sides are inset, and the main reason I inset the sides instead of the front ones was actually just so that the top beam would also be 700. And I'm exactly what I thought. I'm going to run out of room here because this is really big. So let me stand up here and rearrange just a little bit. It won't take much. Maybe a little bit more noise than I want on the camera. But other than that, I think we're okay. Let me move things around a bit. Again, I appreciate you guys joining me. We got, it looks like 10 viewers, so So I appreciate everyone that's watching. Let's go ahead and we got all these pieces, all my components. Some of these are already, like I said, ready to go. I'm going to build this way. Got my mic off the table now, so hopefully this isn't too loud banging around metal components. And I'm going to lay this out. I should go ahead and put on the corner pieces here. And so corner pieces, I've got everything's metal that I'm working with today except for some custom printed brackets I had to have for the ball screw and for the Y motor. Yeah, I appreciate that. Thanks 3D Print Viking for that. Me likes the better. If we can get more subscribers, also good. I've had a great month so far on YouTube. I say month, I've been on for probably 6 months, but I've only really started producing content in any reasonable amount in the past month or so. And so I've got up here, I passed 100 viewers just Christmas, and I'm going for 200 today. So if you are part of any Facebook groups or other forums and you'd like to share this stream, please do. See if we can get just a handful of subscribers before the end of the stream. Let's see here. All right, where are we? So I'm using the standard, these are M5 screws. I've got the custom adjusting nuts that will slide into place. Some people like these, some people don't. I think that they're fine if you can sort of fill out when you install them and make sure that they're actually going in where you want them to. So let's go and put on the corner pieces. Get everything sort of lined up here on the bottom. And if I can get most of the base assembled today, I think we'll be fairly successful. And then if people enjoyed this, if people want to see me continue, then I will live stream the rest of it. List of suppliers. Oh yeah, thanks Cass Todd. I meant to get back to that. The list of suppliers. Yeah, I'll be happy to list where I bought any of these components from that I have today. Go and put those in the video description or in a comment later. Or I will just be posting a full video later about how which suppliers I use, because again, I like good parts. I want to make sure that what I'm buying is quality, but I also don't like overspending on parts. And so, like I said about, I use ZYLtech, which is a good North American company to get all my extrusions. And the price is right, the shipping is great. They have really good filament. Again, keep in mind this is completely unendorsed. This is just from personal experience. I've had good luck ordering from them. Everything ships quickly. If it's been in stock, then it actually ships like it's supposed to. So let's see how am I doing on time. Oh good, we're not even 30 minutes into it yet. So I may even go out of order here if I'm missing parts, because I know there's a couple of steps I'm going to have to do on like my my drill press, and I have not done that yet. I'll explain to you what I'm talking about when I get there. But because of that, I won't be able to assemble, I know, part of it today. But again, I wasn't expecting to finish this. I'm tightening these up for now, but I'm perfectly, expecting to have to loosen them. I know I have a foot I need to put on this corner, on all four corners. May need to go ahead and do that since these are just standard M5s. You can see I got my box here. This is going to be a video coming out about this. This is a custom designed screw caddy that I've been working on. I've got M2 all the way to M5 in here. And these are all 3D printed. All the boxes are 3D printed. Where are those feet? Give me 1 second. think I know where they are, but they're not right here in front of me. So, let me see if it's back here in this caddy. I know I have some more of those rubberized feet. No, not today. That's all right. Those can be added easily. Again, I've got these socket caps and some rubberized feet that will go under these corners. They'll go to here. I can add those easy enough later. Go ahead. Do these corners. All you do when you're installing these, you just line up your heads, and then things will just fall into place. And I am just lining these up with my fingertips. So I make sure everything is as square as possible. And also, to make sure these corners are square, I'm going to be adding corner brackets when I flip it over, because I want to make sure the printer is as square as possible, and this isn't going to cut it without those corner braces. So, all right, last one. If you have any Fusion 360 questions, anything like that, my CAD background comes from when I was pretty young, probably even back to elementary school. My mom was a drafting teacher. My dad is an architect, so I got early exposure to that kind of software. I hadn't touched it in I don't know how long, and then when I got the 3D printer, I actually had a reason to work on it again. So it was pretty easy to pick up Fusion 360. No problems there. So, all right, so I've got the four corners on here. Let me see about these. So, as you can see, I got these kind of brackets for the cross beams. Let's see. These I'm probably going to go ahead and tighten down to the cross beams, but I'm not going to tighten down the ones that are attached to the Y-axis braces. So, where'd that box of screws go? That's what happens when you do this live. You lose boxes of screws. I just had them. Bet you this is going to slow me down a little bit. Where did they go? I laid everything else out here. Alright. Give me a 2-second intermission, guys, and I'm going to find this box of screws that I have misplaced, and I will be right back. Alright, just as I expected, they were right behind my head. That's why I couldn't find them. So, now I have them. Sorry about that. So on Fusion 360, so I love Fusion 360. The timeline view that it provides just really works for me. It's really nice to be able to jump forward and backwards in your build process. I am a very mechanical guy when it comes to design. That's why something like what I'm showing you here in terms of the this over here, in terms of my build, is really kind of easy for me, because if I can measure it and come up with the angles and links and and stuff like that. That's how my brain works. I even do that even if I'm working on more artistic stuff. I try to break it up into its various shapes and lengths and angles and stuff like that. Now my son does not particularly care for Fusion 360. He has used other CAD programs that seem to work with the way he thinks better. He got started with Tinkercad, and that worked for him. My youngest daughter has also worked with Tinkercad and has been able to make some models for school that I've printed. So, big believer in using whatever works for you. So, if Tinkercad works, if Inventor works, whatever. Yeah, the user interface. I think the key to most apps is learning the keyboard shortcuts to as many of the tools as you can. And the reason I say that just because so much of it's easier if you know the keyboard shortcuts. Okay, again, I am tightening down the cross beams this way, but I'm not tightening them down this way. I'm only tightening them down just to get a bearing. And then I'm going to loosen them because I'm going to need that to be able to move around as I position the other components. So I'm going to grab all of these. I'm going to need 4 of them total. I enjoy the design work. I think the being able to model something and then being able to print it and see it come to life is very satisfying. It's really what got me going kind of in the maker space, was getting the 3D printer, building that with my son, and then being able to make everything from a cosplay component that you're looking for or that your friends are looking for, and then being able to even design electronics enclosures for custom projects is really nice. It keeps you from having to go out and work on a metal box or a plastic box that's not really designed to do what you want to. We got 15 viewers. I appreciate everyone joining me. I was hoping that people would have some free time on New Year's to join us for this. So, again, if you haven't checked out my other videos, I would appreciate you seeing what else I've got working on. I don't have a ton posted yet. I'm still getting going on YouTube. I've got a lot of stuff planned. Maybe I'll pull out a box of my plans later. I've got an Iron Man suit that is going to hopefully be something that I have a lot of time to work on this year, because I'd like to have that for Dragon Con. And I've got a couple of other things that I'm working on for other people. Star Wars component that I'm working on. I've got some blasters that I'm working on. I've shown it on Instagram. If you're not following me on Instagram, I post a lot of Instagram and Twitter. I post a lot of my my content there. In terms of just little, I'm working on this little project. I printed this little thing for a friend or for a kid, or something for the house that I needed. I post a lot of those there. Things that aren't really going to be video worthy. Let's see what we got. Speaking of printing parts, what do you think of the Bullseye fan upgrade for the Ender? I don't know if I know specifically which Bullseye fan you're talking about. Rather than me taking the stream time to go look it up, if you want to explain to me real quick in the chat what it does or what it's supposed to do, I may have a better idea. Unfortunately, I don't think the chat will let you post pictures, because that would be a big help. But if I get a minute, or if I run out of things to work on before I run out of time, I will take a look. Had to pause a big Ender 5 print that I've been working on because I was afraid the background noise would be just too much. So I'm printing, you guys can probably see it back here, this bonsai bill. It's something I've wanted to print for a long time, but I actually found an additional reason to work on it, and that was to test. A lot of people on the Ender 5 were worried that the cantilevered bed will bow if you get too much weight on it. And so what I have done is use this, which is almost a half a kilogram or over half a kilogram of filament on the bed. And we're going to take a look at whether it actually causes any warping to the bed just because you put the extra weight on it. I'm not going to give away the end yet because I'm still working on it. But I think it's I hear a lot of people, not just about the Ender 5, but a lot of other manufacturers' printers, they see that cantilevered bed and they go, oh, it's going to bow on one side, it's going to be real heavy, it's not going to set straight, and instead of defending it without any data, I've decided to just do the work, and we'll present that later. Nozzle duct puts air on both sides of the nozzle. That would be wonderful. Yeah, I'm talking about the chat here. So Gary's mentioning that there is a mod for the Ender where it will move the airflow from one side to both sides of the print. I'm actually a really big fan of that. If you guys see on, let's go here. If you'll notice here on my print, I think everybody should be able to see that just fine. I have dual cooling on this printer. And I actually am going to show that also on this bonsai bill that I'm printing. That if you do not cool both sides of the print, then you're going to get uneven cooling. And that's going to be just a side note in the other video. That was a real problem on this one because if you print it in the regular orientation, one side you're going to have overhangs, the other side you're going to have overhangs, but they're not cooled evenly because you only have airflow coming in on one side of the print. So I will check that out, Gary, because the only thing I worry about on like the Ender is that you're going to have a small fan trying to cool both sides of the print. And so I worry that you've really decreased your airflow to the point, but I'm willing to try it out. I was kind of interested in looking at a mod to possibly just add dual cooling to it, but I think it'd be potentially be a pretty big mod to that print head. Anyway, let's see what I've got here. I think I have the base done. Yeah, I agree. Anything for the Ender 3 should work on the Ender 5 in terms of the hot end. Let's look at this. I've got all that set up. These are going to be, let's see if you can see this. I'm going to zoom in enough to hopefully where you guys can see what I'm talking about. So this bracket here is actually going to end up being two of these brackets next to one another. And if I don't like that, then I will probably go and 3D print one piece. But I think the metal is still going to be a better solution. But we'll see. Alright, so I think this is good enough to start on the Y-axis movement. Alright, so let's flip this over again. These are still moving, but I don't want them to move too much. Hopefully let's make sure they don't fall out just by tightening these just enough to where they should latch on. I don't want them to fall out while I'm working on it. And I wish I knew where those feet were because they would actually protect the table here. I'm going to have to be careful not to scratch up the table any more than it already is. All right, so let's flip this over. There we go. Let's bring this up, see how it's looking. I think you can see what's going on here pretty good. Yeah, I'm sitting down most of the time just so that I'm in frame and you're not just staring at my shirt. Let's go ahead and start and get the movement portions of this. I am grabbing, so these are the rails. So while I'm working on this, I want to go ahead and address some of the issues that people have already brought up. Let's see, I've got a chat from KS Todd, or actually from Gary. Yes, Gary, that's exactly right. So it is 4 beds. I have 4 of these 200 by 300 beds here. There we go. And I decided I wanted to go with these because they provide a very even surface. They provide even heating, and they can hook up to a standard power supply, so I don't have to go to mains like you do with some of the ceramic heaters. I wanted to be able to go to a power supply. Let's see. The only issue with Ender 3 parts on Ender 5 is that I can see is that the drive belt for the carriage. Okay. Thing of burr space for Ender 5 bed. Okay. Yeah, I've heard people talk about the bed brace. I'm willing to install it if I find that there's actually a problem there. So I head back to the beds. These are 200 by 300. I'm going to have 4 of them next to each other. The base plate, I'm going to show that while we're talking about it. Here is the base plate. Again, this was, I CAD'd out where I needed all of my holes to be. And the exact dimensions of this, which is not exactly 600 by 400. These beds are a little bit larger than that due to the holes. I think it turns out to be 640 by 440 or something like that. And then I went to a local laser cutter, water jet cutter, and he made this for me. Again, if this works out, if it turns out to be a great printer, I'll be happy to actually run a bulk order of these, which will save a lot of money over doing one-offs of these beds. Anyway, that's the plan. If you'll notice, for today's build, I haven't done any soldering to these beds. I haven't put any of the wiring on them. I want to check out the mechanical parts of this printer before I have all of the wires in the way. So I haven't done any soldering. These will be easy enough to pull back off. So let's get the rails. Let's talk a little bit about some of the concerns people have already had about this printer. There are a lot of printing enthusiasts that have been doing this longer than I have. There are a lot of people that know about mechanical systems, and they're mechanical engineers. And they wonder why I went with these rails over doing the linear rails that I plan on doing on the x-axis. And for me, it was actually a pretty straightforward reason. The main reason I did not go with the linear rails on this bed was because if I went with this system, if I went with the ball screw with these rails, I needed no additional printed or machined parts to put this together. It means that from the frame to the bed, it's all metal. It's all screwed together components without any additional shims or anything like that. If you go with the linear rails, the ones that I'm using on the x-axis, you would have to put something else in there to be able to do this model. So for me, even though technically the linear rails are smoother, more efficient a rail system, it did make sense to me. I wanted this as rigid as possible, so that's where that came from. Let's see here. Shout out to my followers on Instagram. Sure. All right. Appreciate that 3D Print Viking. We're up to 17. Beats the heck out of the first stream I did, which I think I ended up with 3 or 4 people. But that was when I had no contents, before people had really seen my Ender 5 review. So right now that Ender 5 review is kind of carrying me along. So if you've seen that review, if you've liked it, if you've shared it, thank you very much. I've had a lot of positive feedback on it. And so more printer reviews, if any manufacturer wants to send me some. I have the printers I need for now for personal use, so I won't be buying any more, but I'll be happy to take a look at them. So let's take a look at these rails. So these things, super rigid. There's no flex, no bending in these. As you can see, this is a... pull out the calipers just to make sure I don't tell you wrong. These are 16 millimeter rails. Again, I'll be happy to post a BOM of this whole printer later, a bill of materials. So the reason for the cross bracings is these come pre-drilled with holes at specific intervals that actually line up to where these are put together. And so I needed the cross bracing to actually line up to those screw holes. That's what those are there for. If you'll notice, the screw holes here have to match up to the screw holes there. And so that's what I'm working on. So I'm going to lift up on this a little bit. Actually, you know what? I have forgotten that we need to do the corner braces first before I do these. I want to make sure that my bottom frame is square. Otherwise, I'm going to be readjusting everything later. So let's get all of this squared up first. So these are really beefy corner braces that I got from ZYLtech. I had some that I'd ordered from a Chinese manufacturer, I think from AliExpress, and when they got here, or maybe even Wish, and when they got here, they were just small. They didn't have enough area. They weren't as long as these are, and so I wasn't happy with them. So I ordered these from ZYLtech, and honestly, I don't think they really cost me that much more than the ones I ordered from overseas, and so I'll find some other projects to use those on that are smaller than this one, but I really needed the bulk for these. And so what I'm working on now, let's see if I can switch the close-up one for a minute. Of course, if I do that, I'm going to have to actually show you the corner that I'm working on. So let's do that for a minute, just for a change of scenery. So what I'm doing on here, same screws and nuts that I've used on the other parts. Again, these are 5mm screws. They are, let's see, M5 screws, 10mm long. They have hex connectors. And I like the hex connectors. They don't strip out on me. And they make for a much better connection. Again, if you're attaching these, make sure you line up the connectors. And actually, these will fit through here, which means you could pre-attach them. But these are going to be used to square up these corners nicely. And I'm putting them on the opposite side as the angle brace was. And I'm going to move these all the way out to the edge Okay. Yeah, I'm gonna move this one. I think that one did not grab hold. What happened? Oh, okay. So it looks like these may be too long for this. Let's take a look. So if you look at my usual, these are the brackets I'm using. These are 4 millimeters. These though, let's see, are these 4 millimeters too? Nope, these are 3.5 millimeters. So I think we're going to have to go with some shorter screws on these, because it looks like the screw is actually bottoming out into the rail. Luckily, I have some. I have a few. Let's see if I have enough. So these are 8 millimeter, which will not bottom out on me. If I need to order more, I will. Let's see. I guess I can go ahead, since not a lot of chat's going on, I can talk a little bit about concerns I have. I think the first concern I was talking to someone about on Facebook. Again, if you haven't checked it out already, check out my Facebook page as well. I probably don't post quite as much there as I do Instagram and Twitter, just because, you know, it's not quite the platform to just post a bunch of photos. But let's see. There we go. So again, these should not bottom out. But again, the first concern I'm going to have on this, I think, is going to be this, the motor on the Y. So the Y-axis, if you've seen the picture, the Y-axis is going to be driven by a ball screw. And rationally or not, according to some people, I'm not a big fan of belts. I like the mechanical, the hard pieces. So I really like the ball screw idea for the Y-axis. And so I'm worried that the standard NEMA 17s are not going to be powerful enough, so I may have to go to a different NEMA size. NEMA 23, I think, is the next size up that I would try. But we will see if that's necessary later. Alright, so that's how you square up your corner. Again, I had to go with the 8 millimeter screws on this. The 10s bottomed out into the rail. But that looks pretty good. Let's see what I did here without making you too ill. There we go. Alright. Let's go back to the wide shot. There we go. Okay. So now I'm just going to put in the rest of these corners. Again, I hope I have enough of these 8 millimeter screws, otherwise I'm going to have to order some more. Because it is clear that it does not work well with tints. Again, thanks for spending your New Year's, a couple hours on your New Year's here with me. Hope 3D printing is what you had in mind for today. Obviously, you came here. Obviously, there will be no 3D printing today. It's not going to make it quite that far. But, like I said, I'm happy to talk through the mechanical aspects of this. A lot of people have questioned why I would make a moving bed in this day and age of moving, you know, of Core XY printers, of HBOT printers. Why would I move the bed? Again, I think this came down to me having an idea for design in terms of using a ball screw, making the bed rigid to the chassis. That I just really wanted to give it a shot and see how it works out. Not bucking the system just to buck the system, but actually see how well it works with the ball screws. chat has gone quiet, and we are down to 11 watchers. Apparently this is not the fun part of the build. So apparently I should have assembled this part ahead of time. But feel free to put on your own background music. I would put on some, but you never know what YouTube will get upset for in terms of copyrighted music in the background, so I didn't want to mess with it. But normally I would definitely be working with music in the background or TV on or something like that. So. Oh, I think I lost that one. My phone is dying now that I'm leaving it on the whole time. That's alright, I'll go get a plug if I have to. This is what sometimes people don't like about these screws, is sometimes they don't want to move and catch like they're supposed to. So, let's see if... Again guys, if you've got any Twitter feeds, if you're on Instagram, any bit of advertising for my channel, I appreciate it. If you enjoy this kind of build, please like it, and I'll know that this is worth doing live. Otherwise they will become pre-recorded and I will edit everything down and it will be way less interactive. But I enjoy this part of the process of actually putting things together, and I was hoping other people would too. Let's see. Well, you know, you're right, Gary. And at this stage, as I mentioned, I think in the video description, there are no instructions. This is all off of my CAD drawing. I don't think I would do a lot of instructions at this stage in any design. I actually have another build going on in my basement for Science Olympiad, and that project is actually at the point that I might be writing instructions for it. So I usually wait till I actually know whether the process is worth doing or whether there's some sort of fundamental flaw before I start writing instructions. You don't want to spend a lot of time on documentation if it's not going to work out anyway. So, there we go. Maybe it'll get more interesting here in a minute after I get these frame braces done. And we start getting some Y motion in place. Not happy with these at the moment. They're not wanting to grab hold of the extrusions. There we go. Grabbed hold that time. I lost a screw though. There it is. Just for people wondering, you know, once I get this all assembled and it actually is printing, I am more than happy to actually do a review of my own printer as if it were something off of an assembly line. Judge my print quality, judge the print speed, all the things I would judge on a off-the-shelf printer, because again, what's the point in doing this yourself if what you produce isn't what you were hoping for? Now that I've got all this assembled, I'm kind of going to see how rigid it is at this point. Let's see. Gary is asking, have I ever sold anything I've printed? Yes, I've actually only sold one, maybe a couple of things. I printed something for a family member and I sold it to him for cost. and that was just, he had a Christmas present he wanted to do for a friend, and he covered my materials, and that was about it. It was someone else's design in that case, and so I definitely didn't charge for the modeling or anything. I sold one cosplay component, and that was fun. So I designed it for a 501st and Rebel Legion member who needed some armor. She was just doing part of the armor. I met her at a 501st event, and I modeled it for her. I got it printed. I finished it for her, and then she took it from there, did some weathering, and some added some stickers and stuff to it that she needed. She did all the vinyl work and everything. So that was the only thing I've sold. I've never sold anything that someone else designed and that I printed even one or two of. So this is done in terms of just the corners are assembled, and this doesn't move at all. So some people were trying to tell me that this was not going to be rigid, that this structure is not what they would consider a rigid structure. Maybe if you're a mechanical engineer, that means something different than it means to me, and I'm more than happy to concede to that. But this doesn't flex. I'm trying to flex this, and it's not flexing at all. And I'm not even done assembling it at this point. We still have these cross braces that have to be assembled. There's still going to be the actual rails on here, and I'm really happy that this doesn't have any flex in it at this point. Everything actually screwed in real solid, and these are still sliding, which is nice. So now let's get the rails on. And with these things, if I'm not happy with how solid these are, I can also put braces here. I can put braces on both sides if I really want to. I mean, we're only going to make this more rigid as we go along. So let's push this all the way up to where the screw holes are going to be. And this is great. So let me switch over to the close-up camera here, because I want to show you what I've got here. Actually, let me go back for a minute, because I don't want to really bother people as I take this camera here. So I'm going to find exactly what I'm looking for with this camera, so that people can see what I'm talking about. This is a lot harder than it seems. Okay. So this isn't going to be the best shot, but I'm going to do my best. So let's transition back over to this. Okay, as you can see in this shot, these almost completely butt up against each other. Now they're not going to exactly. This is the cross brace here. And then this is the corner brace right here. And they almost butt up to one another, but they don't. So this is going to be great. No mechanical problems there. Okay. So now let's work on assembling. Let's move this out a little bit. Maybe I can show some of the assembly here a little bit closer up. And that just deafened everyone on the stream, so my apologies for that. Not part of the plan. Alright, let's switch back over. Okay. Again, sorry for the mic drop. Not in a good way. Alright, so again, we're going to line these up here. A lot of this is still going to have to stay loose. I could measure it out, but let me show you this. So on this printer, I have put... don't have my camera up. So on this printer, I'm actually putting the Y stop on this end. And you can't see. There we go. So I'm actually putting the Y on the max because this will actually max out here, which it will not max out on the other end due to the way that the ball screw works. So this is a custom designed part. You notice the end stop works really well. It will butt up against this when it hits the maximum. So that's a setting that we can change in Marlin. And so I actually can put this here to line up this once we get everything lined up. I've already verified these M5 screws should be fine. Let me double check. So this is, yeah, this is almost 5 millimeters thick. So this will work with the 10 millimeter screws without any problem. So go ahead and get these in here. Again, this was the design idea that I had. I wanted everything on this side rigid. I did not want to have to make plastic components that were shims for better rails. I didn't think that that was a good idea. Shimming up with plastic or having to have custom metal parts machined so that I could use the other linear rails seemed like a step backwards to me. Always happy to hear feedback. I don't want to make a mistake that's costly or a mistake that doesn't make any sense to someone that's done this before. But as I posted on one of Joel Telling's videos, the 3D printing nerd, he's working on the Open RC Racer that's been printed a ridiculous amount of times larger than the standard. And a lot of people have given Joel flack for doing things that they knew were going to fail or doing things that they knew just would not work. I actually give Joel a lot of credit because he did it anyway. And what I mean by that is it's nice to see the experiment sometimes. It's nice to see what happens if someone does that. You know, I think it was, you know, Adam Savage and the Mythbusters who said failure is always an option. And it's sometimes fun and educational to see how things fail rather than just having people tell you that they're going to fail. Joel was able to test out his first Open RC and it did fail as people said it would, but I think it failed a little bit different than people expected. Same sort of, you know, idea and methodology in terms of why it failed. Plastic on plastic is not a good idea in terms of moving objects. But he was able to demonstrate it. He showed how it failed, and now they can move on to doing another test. I got 15 people watching. I appreciate everyone joining me. Let's see how far apart these are going to be so that they're at least roughly in the right spot. So if I put my bed on here, notice the bed does not extend past the boundaries of the frame. That's for safety. That's because you've got vertical bars here that you really can't go past anyway. And these are actually a little bit further out than I expected. So this is where they are. So I'm going to line that up there. I'm going to go ahead and tighten these down for now. They're easy enough to move later, but I think I need to tighten them in order to get this thing put together square. Again, when you're using this kind of nut that spins around, look in your extrusions and make sure it's catching on. You'll save yourself a lot of headache in the future when things aren't lining up for some reason and it just turns out that it wasn't in the right spot. Same thing on this side. I'm going to kind of line it up to where I think it should be. I can probably measure this on my drawing. Let's see if I can measure this. Maybe it would give me a better result. So hopefully you guys are seeing this. Maybe I can go to a full screen. Let's see, where's the Y? Not that one. There it is. I'm going to switch over to the full screen of... No, it did not transition. What is going on? Just a blank screen. Let's try that again. Transition back to this one. Huh. So now Fusion just isn't sharing at all. There it goes. Let's try one more time, because I think this is interesting for people that are new to Fusion, maybe. There we go. Okay, now it's showing up for all of you. That's what I was going for. Let me grab my phone so I can see what you guys are doing. How thick is this plate? Any concern with bowing? No, there's no concern with bowing of this plate. I am going to do the measurement for you. I remember it, but this is probably a standard unit plate. It's probably 1/8 of an inch. Hold on, I'm actually going to see because I'm guessing it's in inches. Yep, 1.25. This is 1/8 of an inch thick. In millimeters, that is about 3 1/4. And this is really, really here. On the wrong screen at this point to show this to you. But this is really, really thick metal. Very. Instead of me just continuing to talk, let me switch over and show it to you. All right. All right. So now I can show it to you. So, any bowing? No. I am trying every bit I can, and I can bow it with my thumbs. But I'm really, really putting a lot of pressure. And once this whole frame has been screwed together, and this has been strapped down here, I don't think there's any chance that it can move at that point. Plus, on top of this, we're adding these additional 1/8 plates that I'm actually hard screwing down with brass posts. So, no, I don't think there's any chance of bowing on this bed. There's too much holding it in place. So, let's go back over to the screen capture. All right, so let's go and do a measurement here. Maybe this is the best way for me to do it. So, in my CAD drawing, if I measure from here to here, it should give me a rough idea. It looks like it's almost 82 millimeters if I'm even grabbing the right edges. It looks like the right edges. So maybe I can grab some sides here just to double check it. There. And let me... There. Yeah, 81.75 millimeters. Better way of doing it. Now we know exactly what I'm going for. It's not going to be exact. I can square it up later once I get all of the motion on. So let's switch back to one of the other wide shot transition. All right. So thanks, Todd, for the question. So let's go and I'll grab my ruler here, and let's actually make sure that we're roughly in the right spot. Because again, even the plate was designed in that same CAD drawing, so it should be accurate. 81, almost 82. Right there. Let's do it. Check. Yep, 81.75. That should be almost exactly where we want it now. Making sure my screws line up. And that should square up pretty good. Same thing over here. They should be equidistant, so we'll do 81.75 on this side. Okay. I'm going to screw in the outside one first. Yeah, this one is not wanting to catch over. There it goes. Okay. Dave, good question. What are my concerns with the bed leveling? I have some concerns with the bed leveling because obviously it's I'm making it rigid. And will a rigid bed be a level bed? And the answer is I don't know yet. So again, my initial thought is I'm going to make it all rigid. The frame is rigid. I'm then directly screwing down the rails to the frame. And then I'm going to use the brass standoffs to connect the beds to the frame, or to the large plate. I'm hoping that gives me a mostly level bed. And what I mean by mostly level is a bed that can be compensated for due to its size, a bed that can be compensated for with actual bed leveling with the ZYLtech. So here I already have a bracket printed up. Let me switch over so you guys can see what I'm looking at. There we go. Okay, so here's the print head. It's going to go onto here. This was all custom designed for this printer. As you can see, this is going to be this is my print head. We got the ZYLtech just probably a centimeter from the print head. And if the bed is level enough, and again, I'm not using a engineering or a scientific term there, but if it's level enough, this will compensate for it, because what will happen is we'll tell Marlin to do a bed leveling check. I can specify the number of points on the bed. It will then map out the bed and be able to compensate for such a large area. If it turns out I'm wrong and it's just not level enough, then luckily I still have 4 print beds. And if I want to, I can get rid of the rigid brass standoffs. And instead of the brass standoffs, I can actually put, the standard adjustment screws, which mean that each bed could be leveled separately if I needed to. And then on top of those beds, I think earlier it was asked what my final print surface is going to be, and the answer to that is I'm actually going to get one big glass sheet that's going to sit over all of them. So if the rigid bed system doesn't work, I will then scrap that, go ahead and do the same design. Nothing changes except for the standoffs. Then I can level each of the 4 beds and then put the glass bed on top of it, which then can be auto leveled after that. So I have some options here in the design. Nothing about the design as it sits right now is set in stone and precludes me from changing that leveling technique. So let's get these last 2 rails in place on the ends. Again, I'm set in terms of where I have to put these cross braces because I already have holes in my rails, so that determines where these are going. Again, 81.75 on these on the distance here. I can tighten down. I'm going to need to make sure that it is actually catching. If it's catching, I'm going to... Yep. Alright, let's grab the other one. Maybe 1.75. Give or take. Hopefully that grabbed. Looks like it grabbed. Okay. So now my rails have been fastened to these. Notice the whole thing moves together because I haven't actually fastened these down. And if I slide everything into place, it actually lines up really nicely. Actually, let's see if I switch over to the close shot again. Yeah, I think you'll be able to see this well enough. And these, the whole system here right now is sliding. And these are lining up really well. And I'll be able to even line them up better once I turn it over and screw everything down. I think it's safe to go ahead and do that next step now of actually fastening these in the right places, because these are not moving in terms of this direction. Sorry for that shot there. Okay. So let's flip it over and we'll get this fastened to where it needs to be. And I'm being careful here, don't want to scratch up my table. Also, don't want to have missed something and everything just fall apart. So, let's tighten these up at this point. I'm going to line these up. See if I can get a good shot on the close one so you can see what I'm doing. And I think you can see it here. Going to transition back over. All right. So what I'm doing here is, per my design, and particularly since I have that end stop here, I need this rail to be not overlapping, but butted just up against the edge of this front rail, of the front support beam. So I'm going to line that up. I'm going to eye it as best I can. Okay. And I'm going to go ahead and tighten one of these down on this side. Okay, and we'll come over to the other side and do the same thing. I'll line this up. So I have the best I can. I'm going to tighten this one down. And you have to be careful when you screw these down because things want to move around on you. So it's constant adjusting to get it square. And then I can go ahead and make sure these are clamping down like they're supposed to. Make sure that's still square. Up to 16 viewers. Thanks everyone again for joining me on your New Year's Day. I am going to try to keep the hard stop at 4. We make it as however far we make it, and then we'll just do another one of these if you enjoyed this and you'd like to come back. All right. So now that I've got the front ones done, let's get the back ones down. And I can tell if these are clamping down like they're supposed to. Kind of get a feel for it. You can tell if it is or isn't. I'm pretty confident these are in the right place now. Again, since these rails have very specific locations for their mounting holes, that's not going to change, even if I have to move the rails in or out a little bit. Hopefully I won't have to move anything. All right. So let me take a short intermission here now that we've got the rails attached. Again, here is the printer. It is not moving. It is extremely rigid at this point with all of these braces and stuff. Again, I actually probably will come in here once it's almost finalized and put a couple more braces here since this is going to be part of the motion system. So let me take a really short break here. I'm going to get me a drink since I'm talking so much. And I'm going to get my phone charger so that I don't run out of juice there for the commenting. Please, again, if you're on any sort of social media, please share this video. Please tell other people, hey, there's a live stream going on. Someone's building a printer. And share my channel. Thanks again, guys. I will be back in under 5 minutes. That's the plan. All right, I am back. I have gotten one of my favorite Decepticon glasses of beverage. So, Anyone that's still there, please say hi. Say hi. I am actually going to spend 1 second and see if I can do a quick shout out for the last half an hour of this stream, which honestly was my fault for not doing in the beginning, because I should have done that to begin with. But this was already up on all of my feeds that I was doing it. So let's do all of these. Let's share this. Hey, new subscribers. Thank you guys. I appreciate you joining me. Thanks for subscribing. Hello, Todd. Thanks for being here. Let me just do a quick post. I'm just going to do a lot of hashtags and see who shows up, because I don't want to take up all of your time for joining me. So this is going to all of my feeds: Facebook, Instagram, Twitter, streaming live, custom 3D printer build. Let's see. Okay, well, Instagram doesn't seem to like it, so let's turn that one off. Now we can post. All right, let's try to finish up the Y-axis movement here, because that's really where I wanted to get today. So, thanks, Pygar. You have been here for both of my live streams, and I really appreciate that. So let's take a look. We're going to zoom back out here. Hopefully you guys are seeing this up in the upper right-hand corner up here. And now let's move on to the bed. Okay, so let's show you what I've got here. I have, let's see, close shot. All right, so here, this is the custom bracket. I've been through 2 of these designs. One of them based upon models that were wrong that I had downloaded from various sources on the internet about the length of my ball screw. This one should work though. I've already assembled it because I had to test fit this before we even... Hey Gary, thanks for still being here. Because I had to test fit this before even doing the live stream. I didn't want the big disappointment on the live stream being, hey, look, the ball screw doesn't even fit. We're done. So this has been test fit. I have not taken any of the build this far. I've just laid things out on the table. So hopefully it's close enough to actually assemble. So what you see here, this is where the ball screw attaches to on the motor end. This is the actual motor mount here. That's going to attach to the top of the rail. Notice I've got even the screws are recessed the way that they should be. This is my Y Max right here. And I think the last piece I will need for today, given that we're already running low on time, is going to be the other end of the screw. So let me grab it. Grabbing a bunch of parts off camera, guys, so that I am ready to go for this last. So these are the rails that go on to those. These are the ball bearings. This is the connector for the lead screw, or excuse me, the ball screw. And then the last piece I need is that other end, which I know I pulled out earlier and has probably got put under something at this point. But it shouldn't be hard to locate. So hopefully everyone is listening, not just. So we'll go without it if I can't find it because I don't want to hold this up any longer. I know it's here somewhere. It's pretty important to the grand assembly of things. So let me go here. Now I'm going to go to the other end. Okay. Transition this way. All right. So let's show you how this goes together. So as I mentioned, I've already pre-assembled this piece. This has already been attached to where it's supposed to go. I've already got the screws in here. This is going to line up right here for the support of the ball screw on this end. Oh, and also, we've got a place for a foot here that I'll attach when I find the feet and then attach them to all four corners. So that will support it against the surface. I don't know if it's going to be strictly needed, but I'd rather have it than not. These screws here are, what did I say these were? These are M5 35mm screws, and they have embedded nuts in the bottom for support. So let's get this in here. Again, I have these cutouts all in place for these screws so that everything lays flush and doesn't damage the plastic. I'm not going to completely screw this down. I'm not going to tighten this down yet because it still needs to be able to slide side to side until we get it in the right place. That goes there. So when I am modeling these sort of components, I found that 5mm is what you need these the thickness here in order to use the 10mm screws that most people use for the connectors. If it's any less, if you start getting near 4 or under 4mm, as I showed you on those other components, the screws will bottom out on you. So that's useful. There. Need a magnet. And then this is going to go right here, and then we would come in afterwards and attach there's going to be a connector here to attach the ball screw to this motor. Again, if this motor turns out, I'm not showing it to you. Again, if this motor turns out to not be powerful enough to turn this ball screw at speed, which is what we want, high speed, high torque, then I'll just move up the stepper size. Given the fact that the bed should not go all the way to here, if we need to increase the size of this mount, it's not a big deal. That's something that can be remodeled pretty easily in Fusion 360. So, let me see what's next. Again, in the edited live stream, which I will post later, this will all be edited out, all these flat parts. But thanks for, let's go back to the wide shot here. Thanks for sticking with me. So let's take a look at the motion here. I actually go ahead and put on this end stop as well. It's not important at this point, but just to get a feel for the whole printer. And this, I'm not 100% sure if this is going to be centered on here, depending on how these bearings butt up against it, I could move it to the left or the right to get it, making sure that end stop is right where I want it to be. I think. Okay. Again, these are M5 screws. They go through the whole piece, and it really strong. I can't really even bend that away from that piece at this point. And I'm still looking for the other end of that ball screw that I have misplaced. But let's take a look at the ball screw, even though I'll continue to look. So this is a ball screw. If you are not familiar with what a ball screw is, you are probably not alone. I'm sure there are plenty of people that have been working with most of these consumer 3D printers. I've never seen one of these, so let's take a look. So a ball screw, let me switch over to the close shot that you can see what I'm looking at. So a ball screw is a lot like a lead screw in terms of how it works, meaning when the ball screw turns, it moves this component up and down the screw. Now the difference is that the way these are machined, these actually have ball bearings inside of them, and it's a much smoother movement with a lot less torque required to turn this screw. So for high speed, for a lot of motion, this makes a lot more sense. The lead screws that we have on most of our Z axes are only particularly good at moving the small amounts needed to raise and lower the prints. Let's see. Hey, Robert. Nice to see you. I'm looking forward to seeing how it prints too. I can't tell you how long I've been working on this design. I've had parts sitting in my house for quite some time. So let's go ahead. We've got the motion pieces here, the ball bearings. These may need some oil. I actually do have some. Not too concerned with it at this point since we're still in the assembly process. We can oil up later. And these components also have screws here and here for adjusting the how well it fits onto the rail. And let me show you these in case no one's... So that's what these look like on the inside. They have ball bearings. Looks like they each have 1, 2, 3, 4 sets of ball bearings on the inside. And so these all should very well line up with my print plate. Get rid of some of the garbage. I'm still looking for that other component that I've been needing. I put it behind me like I put other things behind me. I don't see it. So this component here actually goes directly onto here. And again, these parts are all from ZYLtech too. The rails as well as the ball screw. These are all standard components that they stock. And at prices better than I can find on Amazon and comparable to what I could find internationally. Plus, they ship locally. They ship, I believe, from Texas. So no problem getting them here in a reasonable amount of time. I didn't have to wait a month like I do from things I order from overseas. All right, so this end of the ball screw will go in here. Again, let me see if I can get this close up. It's not the best angle, but I still think it shows better than the wide shot. So there we go. So you'll see this goes directly in here. And then this, we'll take one of these. And this will fit a NEMA 17. This will fit the ball screw. And now that I've got it in there, it doesn't want to come out. So let me give myself a little bit of torque here so I can pull on it. There we go. NEMA 17 in one end, ball screw in the other. Doesn't fit. Goes there. Put this back here. I'm not tightening everything up at this point. And that goes right there. So as you guys can see, my 3D modeling, again, this was the second go. I don't want to make it sound like I did this 100% right the first time. But my 3D modeling at this point is spot on. Everything is fitting together as it should, with a little bit of, give here. I really do need to find the other end of this ball screw so that I don't screw anything up, torquing it. So give me 2 more seconds of intermission, and I'll be right back. All right, 2 seconds. It actually turned out to be right. So I found the piece I needed. It was actually still in the box. So here is the other end. Again, as I was explaining to you, this whole design was based on the idea that I did not want any of this part to be non-rigid. So same thing on the other end. This goes directly to my extrusion here. So, and I'm trying to make sure that you can see as much of what I'm doing. So let me switch over to the other end again. All right, so here we go. You'll see this has nothing but an embedded ball bearing. That's what controls this end and keeps it rigid. So what I want to do is I want to get this in here. Let me move some of this around a little bit. I'm going to go ahead and take back off the motor on this end while we get this squared away. And then that will allow me to push this in all the way. And get this all the way in here. I do not want to bang on this. This should all go. It's just going to be tight, which is what we want. We want all these pieces to go in tight. There we go. Okay. So that's in tight. And once I'm ready to call this in there for good, it comes with a little lock piece. This catch goes around the end of this rail here to hold it in place so that it does not come out. Okay. And I'll show you on this end now that it's all the way in. So let me fix my sound here. Okay. So this is all the way in now. So you'll notice this whole rail is one continuous piece. This end is bolted directly. This end I did not have a choice because, again, with the dimensions, there was really no way to put another extrusion here. And due to the mounting holes, here, it wouldn't have gone straight into an extrusion anyway. So I had to do this. I'm not too concerned about it. With all of this being rigid mounted, with all of this being rigid mounted, with this being rigid mounted, and this being a really bulky piece of plastic that I've designed here with multiple bracings, and with the foot underneath it, I don't think it's going to have any problems. So again, I still left this to where it can slide left and right because I have to line it up with the bed. Alright, let's get rid of some of our plastic here. We're going to leave the motor off for now. I think that's a given. I've shown you how it works. That can be put back on later. We have this little nut here that also goes on this end. Just like, you know, the one for the other end. This will be rigid in the Y direction as well. Again, 14 people in the chat. I appreciate everyone being here. We've got about 10 minutes officially in this stream left. I'm going to try to get the plate mounted on here because I would like to see it all moving if we can. So we may go just a little over, but I don't want to keep anyone longer than we need to. So this is the point of doing a live stream right here. I left that off, so that's not useful. And now I have to actually pull this back apart. With all of that, getting it together. I'm going to come off now. If anyone wants to mention in the chat next time before I do something like that, that'd be great. What's great is my hands are getting super greasy here. So I'm going to have to go get a napkin at some point, otherwise everything's going to be greased up. So these pieces here, I've got mounting screws. They have to go into this side. That will go there. It's interesting is it did not come with screws that I remember for that mounting. Nope, it did not. So I have to supply my own. Let me go get a paper towel real quick. Okay. One thing, I'm not too worried about losing grease onto my hands here because I do have some grease for this later that I'm going to put on here before I ever run my first print. I'm going to grease up the rails. I'm going to grease up the ball screw. So let's see what I'm going to need here. These are M5 screws. So let's get some M5s that are long enough. That's probably too long. Looks like M5 16s. Still too long? M5 12s. M5 12s may work. And I think M5 16s are going to be better if that's not too long. Let's go ahead and put one of these in and see how it does. Like I said, Gary, I actually would be printing still also if I didn't want the background hum to just bother you guys. So yeah, M5 16s are the right length for this. So let's get some more of these out. We need 6 total. There's 3 on each side. So let's get these in. Actually can put back on the other end now. It'll keep it from banging around, potentially torquing the screw the wrong way. There we go. I am not going to tighten these down. I just want to make sure it's in the right place. Robert, I appreciate that. That's the kind of feedback that will make sure that I live stream the rest of this build. So anyone who has been here this whole time, if you've shown up late, if you've just joined us, thank you very much for joining us on New Year's Day. When I say us, I mean myself, all of the people that are in the chat. Appreciate you being here. Please like this video. Let me know that you want to see the rest of this streamed. I enjoy this. I think it's fun doing it live. I like doing it with other people that enjoy this kind of thing. You know, I think a lot of us do this kind of in a solitary mode where we either stay up late or we do it in our downtime. So anytime we can get together like this on a live stream or a chat or whatever and kind of share kind of our passions, what we like to make, what we like to build, I think it's a good thing. Now, one thing I'm noticing while I'm doing this, in the back of my head I'm going, this would be much better with lock washers. So I will probably come back in here later and put lock washers on these because I don't want them backing out later while this thing's moving, you know, who knows how far during a print. So I'll probably add some lock washers to this. This will work for what I'm using it for right now, though. Okay. So, again, just going off of my top of my head here. Let's see how the plate fits. Okay, so I think this is a good camera angle for this. Let me know if you can't see what I'm talking about. I'll try to do better. But what we've got here is these are centrally mounted on the plate. We've got this one for the motion on the ball screw, and then we have two over this side. Ideas behind why it's designed this way. Why are these inset here rather than being on the edges? Well, it has everything to do with the motion and the depth of the machine. So if you move these out to the extents of this machine, what you've done is made it where your machine has to be that much wider. Okay? Not a good idea, because at that point, then your machine keeps getting longer and longer. And it's going to be hard enough to find a table that's going to hold this anyway. I'm pretty sure I'm going to have to build something custom for it. And I was concerned at first when I moved these in rather than out because I didn't want any bowing on the edges. But between the thickness of this, the fact that I'm going to actually put 4 more pieces of aluminum on top of this, and the fact that the weight is not, the weight's going to be central on your bed, and these are going to be rigid. I don't think you're going to have to worry about any bowing on the edges. I think that's, unless you're sitting on the side of your printer, let's be honest. Suggest Loctite. I don't know if I want to do Loctite on it. And the reason I just say that is because it really gets in the way of maintenance. Now, if I find I've been running this for a couple of years and it starts to back out for some unknown reason and I haven't ever touched them before, then I may go put Loctite. But I'm a maintenance guy. I like to be ready to work on something, and I feel like if I put Loctite on something, then I worry that it's a little too permanent. And then I won't be able to change it later. So let's go ahead and let's see if all this screws down. At least I'll know if everything is straight. So I'm going to try to get all of my motion pieces lined up in the right holes. Okay. And everything so far is lining up beautifully. Okay. And the center one. Now keep in mind, this one I can't just push because it is attached to the ball screw. So I actually have to move the screw in order to move the piece. And I'm actually on the wrong side to do that. So I'm going to get it roughly in the right place. Let's see. Actually, may have been roughly in the right place. Yeah, it actually was. This does have orientation to it. So what I've done is I've planned ahead for some other ideas. First of all, I have strain relief for my bed power cables here and here that I'm going to make custom plastic mounts for. Strain relief here and here. In the eventuality that I don't like the ball screw and I want to salvage the design of this printer, I have actually already built in mounts here for a dual belt system. Okay, that would be where I would run 2 Y motors, on each side, have a belt here and here. So I've planned ahead for other ideas. I hope this one works. I have no doubt that I can get it to work, but if for some reason I'm not happy with it and I want to salvage this design and the parts that I've put into it, I can go to belts if I want to. So. Okay. Really lining up well. Let me go ahead and run this back to where it goes. This is definitely not centered. That can be fixed. I'm going to go ahead and start screwing down these the rails pieces first. Let's see. I'm hoping the M512s should be good for these guys too. And again, same thing on these. I think I will probably end up putting I'll probably end up putting lock nuts on these as well. There's no reason not to. Keep them from backing out because no one wants a jittery printer for so many reasons. The most, I think, being that they will annoy the heck out of you. So here's why you have this water jet cut, in case you're wondering, why can't I just build a template and print this out manually? These holes fit perfectly. So I had this very well planned out, and so these holes are fitting exactly where they're supposed to right now. They're tight. I don't have any give in these holes. I mean, no more than just a little wiggle for centering. I'll be honest, I went back and I drilled my own holes for the adjustments, because there's a adjustment screw straight on this this bearing, and I couldn't get to them, and I've added my own holes, and I only think 3 out of 4 of them are in the right place that I had to drill myself. So again, I will go back. I can fix that with a Dremel. Luckily, it's not a structural component, so it's not the end of the world that I didn't get the hole drilled perfectly straight, but I'm not happy with it. So we got 11 people still hanging on till the end here. I appreciate everyone hanging out. We almost have the full Y motion system complete here. And that is where we're going to leave it today, as soon as I get everything connected. And then I will test the motion just a little bit by manually moving the screws. And I guarantee you, after this build, I am going to need some more screws, because I am running out. The M5s are going fast. So, looks like I've got a little bit off on this one. So everything else is going together, but I am a little off on this end of this rail. So I'm going to loosen this end up, put it back down. Now I've got a little movement that I can straighten everything up like it should be. I'm actually short a couple of M512s. Not the end of the world. And just come back. I'll order some more. They'll be here in 2 days from Amazon. And we'll see if we can get another build going in a couple of days. So, there we go. Hopefully it won't sound like that when it's printing. But it's got some adjustments still to be done. Although if it's that loud, it's going in the garage. But nothing's, I don't know if it's going to be better. Keep in mind, this isn't actually down all the way. So let's now move the ball screw over so that I can line those holes up. Okay. Should be able to use a couple of tins on here. Actually, those are pretty long holes. Let me just use some 16s. I'm not using those for anything else. Again, I'm still watching the chat. If anyone has any comments, any questions before I wrap up here. We are past the 4 o'clock time. But I got to about where I expected to. I would have done a little bit better if I wouldn't have had misplaced components throughout this build. Probably a little bit more organized than that. It's funny. These are too long. The 16s are too long. You'll notice I'm using a lot of hand tools here. I've got just a personal preference when I'm building anything that's precision, that I do like to use the hand tools over the power tools. I don't want to strip any screws out. I don't want to put anything tighter than I mean to. So I'm a manual builder when it comes to stuff like this. So, switching over to the 10mm screws, because they're definitely not going to be too long. Do I have a tentative schedule for these streams? Not yet. I wanted to actually, now that I had a few subscribers, I wanted to see how many people would actually show up and whether this was worth the time to do live. So now that I know that people will show up for these, I am more than happy to live stream some more. I will put up a schedule. So watch Facebook, Twitter, and I will try to come up with at least a tentative schedule for the remainder of the builds until I get everything working. I can't promise you that what I'm doing right now is actually going to move, because I'm kind of last minute tightening everything down here without really squaring everything up. But I wanted to kind of get to the end here now that we're running over schedule. Don't know if you have family members or whatnot waiting on you today. So, but I'll post it, Todd. Thanks for asking. I'll try to even pin it on Twitter if it goes on there. All right. So, we made it this far. Notice it's not moving right now. It's not supposed to, right? Because the ball screw is holding everything in place. But does the ball screw move it? And the answer is yes, it does. And so, at least in principle, we have a Y motion system that will move a large bed. Let's see. Way too camera shy to do something. What is your Twitter name? So I will put those up again. But to let you know, on Twitter, I am KERSEYFABS, mainly because Kersey Fabrications didn't fit. So I had to come up with something short. So it's KERSEYFABS, that's KERSEYFABS. Also KERSEYFABS on Facebook. So the only places I'm actually full name Kersey Fabrications is on Instagram and on YouTube. Other than that, you'll find me at KERSEYFABS. If you need to get in touch with me, you can, again, please reach me on the social media. Direct message me there, at me there, whatever works for you. I've also set up a domain, so getting everything set up on KERSEYFabrications.com. There's nothing there yet. But you can email me at Chris, and that's K-R-I-S, not C-H-R-I-S, but K-R-I-S at KERSEYFabrications.com. And you can email me there. So thanks for the ask. We've got 12 people on here still. Let me see. Anything else I want to finish? So what I'm going to do here to tighten everything up, because otherwise it's not coming off the dining room table, I'm actually going to twist this all the way down to where I can. So by moving it all the way down, this kind of gives me the extent to be able to tighten these down. Okay. Again, touching the ball screw directly has made my hands quite greasy. Anyway, so tightening both of these down. This end is tightened. All of this is tightened. And then if I manually move this all the way down, I should be able to tell if anything binds up here, because I am manually twisting the screw with just the nub of the screw here. I think this is going to take a little bit of tuning to get it to move as good as it possibly can. Yeah, I think it's binding a little bit as I move down. But then again, these have not been squared up. These rails have not been squared up nearly as well as I will before I try to run a print or a test or anything. But now I can go ahead and let's see, last thing, okay. No, that's not going to be any better for this. So anyway, I'm just tightening these up. I want to make sure that before I move any of this, before the next live stream, that I tighten up everything I've already connected. So again, I will have another live stream coming up soon. What soon means is hopefully within a week. I don't know if that means this weekend, if it'll be in the middle of the week. Please leave a comment. Please leave something in the chat. Let me know if what works best for you guys. You are the ones that tuned into this stream. Definitely want to cater to what works best for your schedule. Obviously, I've got a family. You've got families and obligations, and so I won't be able to oblige everybody. But I do plan on doing edits of each of these streams, trying to keep the good parts, cut out the parts where I'm looking for parts. So if you miss one, don't worry about it. There will be edits. If YouTube keeps these streams, you'll be able to watch the full stream. I don't know if it will. It didn't keep my first one. That could have been a settings thing. But again, thanks for joining me. I got everything done today that I was hoping for. It would have been nice to get maybe the heated beds on here, just to sort of show you what the whole thing looks like. But so far, so good. Everything is going together the way I hoped it would. Again, some of these self-drilled holes are not quite where I want them to be, but other than that, I'm happy with it. Let's see, super rigid. So the only thing I plan on doing between now and the next time, I'll probably go and get the feet put on here so that, again, so that it's easier to move around so it doesn't mar up the table. Maybe it'll run a little bit more even. I've got a little bit of off-camera work to do in terms of prep work. The verticals on here are actually going to be two 2040 extrusions that I sandwich together to make basically a 4040 extrusion, but with all the holes of a 2020. So I'm going to do that off camera. I'll probably have a short video or short interlude that I put into one of these live streams that shows that process of combining two 2040s. Before I sign off, let me see if there's any more comments. Let's see. Okay, so I'm in the Eastern time zone. I wanted to do this in the afternoon, at least this stream, in case there are any European viewers that wanted to tune in. I didn't want to do a 1 a.m. my time because that's some crazy time their time, or even an evening East Coast time would be rough for most people in Europe. So luckily I am roughly halfway, between the West Coast and the British or the European time zones. So again, thanks for joining me today. I will have an edited version of this video. I will continue this build since you guys seem to really enjoy it, and we'll see how it does, and we'll keep going through the process together. Thanks again.